you how to solve a stoichiometry question. So first we look at the question. This is the question. The depletion of ozone O3 in the stratosphere has been a matter of great concern among scientists in recent years. It is believed that ozone can react with nitric oxide NO that is discharged from the high altitude jet plane. The reaction is O3 and NO producing O2 and NO2. If 0.740 gram of O3 reacts with 0.670 gram of NO, A. Determine the limiting reactant, and B. Calculate the mass in gram of NO2 formed, and C. Determine the percentage yield if the actual mass of NO2 obtained from the reaction is 0.515 gram. So, before we do the question, we have to look at the information given. So these are the information given that I can identify. The equation and the mass given for both reactant. So A. Now we can do the question. A. Determine the limiting reactant. So the first thing we need to do is we have to make the proportionality of the mole. This is the keywords. So let's go through the solution. So first we're gonna find the mole of O3. So the information given is the mass of O3. So that doesn't mean we cannot find the mole of O3. So we have to use the formula mass in gram over molar mass gram mole -1 equals to and the answer is 0.0154 mole. We have to take at least 4 decimal places to ensure that the answer is exactly the same like the answer given. So second step, we have to find the mole of NO. So this is the formula given. Equals the answer is 0.0 0.223 mole. Next step, before that, this is the given mole. Can you see that? This is the given mole. It means that this mole is already gave to us. And next, we have to make a proportionality. So how to make a proportionality of the reactant? So 1 mole based on the balance equation. Okay, so before we find the limiting reactant, we have to make sure that the equation is balanced. So this equation is already balanced. So just make 1 mole of O3 reacts with 1 mole of NO. So let's just say you want to find X mole of NO. So here you will put 0.015 0.0154 mole. So X is equals to 1 times 0.0154 mole divided by 1. So you will get 0.015 mole. You don't see it. Okay. So this is the needed mole. You will need 0.0154 mole of NO. Of NO. So here are the tips. If the given mole is lesser than needed mole, then you will get the limiting reactant. Got it? If given mole is lesser than needed mole, you will get the limiting reactant. So needed mole here is 0.0154 mole. And we compare with the given mole of NO. So 0.223 mole. So we can see that needed mole here is lesser than given mole. Therefore, P1 given mole is lesser than needed mole. But NO here, needed mole is lesser than given mole. Therefore, NO is the excess reactant. NO is the excess reactant because the given mole is greater or the needed mole is lesser. It's the same thing. Is greater than needed mole. Therefore, the opposite one, O3. O3 is the limiting reactant. So here are the answer, and this is the note. Given mole must lesser than needed mole, therefore you will get the limiting reactant. And you have to remember the keyword. We have to make a proportionality of the moles here. B. Calculate the mass in gram of NO2 form. So, how to do? Same thing. We have to do proportionality. Between what? Between the limiting reactant and NO2. So, based on this balanced equation, 1 mole of O3, 1 mole of NO2. Why we don't use NO? Why we don't compare with NO? Because we only take the limiting reactant. I mean, we have to take it. And what to fill inside here? We fill given mole and not the needed mole. Given mole, not needed mole. Okay, so we fill 0.015 mole of O3, X mole of NO2. So X here is equals to, you're supposed to do like this, but if you're fast enough, X is equal to 0.0154 mole of NO2. So you cut the mole, and we back to basics. You want mass of NO2. How? We use the formula mole times molar mass. So mole here is 0.0154. Don't forget to put unit. And 20 14 plus 2 in bracket 16. Why? Because n of 2, so we have 2 here, and don't forget to put unit too. And every single thing I write here is your mark, so don't lose your mark by your careless mistake. So we press the calculator and we get 0.7084 gram. You can take at least 4 decimal places. And last question, C. Determine the percentage yield if the actual mass of NO2 obtained from the reaction is 0.515 gram. So how to do this? You have to, there's no way you have to memorize the formula. Percentage, the question asks for percentage yield. So the formula for percentage yield is actual yield over theoretical yield times 100%. Because this is percentage in bahasa Melayu is peratusan, so kita darab dengan peratus, 100%. So actual yield here is 0.515 gram. And what is theoretical yield? Theoretical yield is this. We already find it. What is theoretical yield? It is something that, okay, again, theoretical yield is a mass, and we compare with limiting reactant in a simple word. Yeah. So like this, I compare NO2 with the limiting reactant. It must be limiting reactant. And the question asks for the percentage yield if the actual mass of NO2. So we already got the theoretical yield. So this is the theoretical yield. So we just fill in here. Don't forget unit times 100%. So you will cut 72.70%. And that's all. I hope you guys understand. And I'm sorry if the way I deliver is how to say, it still got the hesitation because it's my first time. Okay, so thank you and have a nice day.